So today you're going to be finding the inverse of exponential and logarithmic functions. So finding the inverse is really just solving equations. You just have to be able to approach the equation in the right way, and you're good to go. So remember, when you're finding the inverse, we did review this recently, I believe. This is the notation for inverse. So that's what we're going to be finding. Remember, we're going to change that f of x or g of x or whatever it turns out to be to y. Switch x and y, and then you got to solve for y. So that's the fun part. That's the one where the logs and the exponentials are going to be crossing over. Okay, so we have an exponential here. So we are going to find the inverse of it. Now remember, the inverse of an exponential is a log. So in our answer should have a log. Have a log in it. That's have. But anyway, so f of x changes to y. Switch the x and the y. Remember, just the x and the y. And now we solve. We have to get that y out of the exponent. So one of the easiest routes to take is our log switch. So it's log, the base is 3, of x equals y. Oh my god, magic! It's there. There it is. It's y equals. We're actually already done. So it's the inverse. That just replaced that. Is log base 3 of x. Fantastic. So I'm just going to do a few examples so you can see, the intricacies of the whole deal. So I switched my x and my y. There we go. We'll do that. And then I switched my x and my y. That one has parentheses. I didn't put it in that one, but whatevs. So I have to isolate the exponential. So that means I have to get that 4 to the y, or 4, right here it's 4 to the y, by itself. So I have to divide by that 2. This is the story of our life in this class. Isolate the thing you're solving for. So 4 to the y. Now I need to get that y by itself. So it's log base 4, right? The base to this thing. And the log is equal to the exponent. So that's your inverse. So the inverse of g is equal to the log base 4 of x over 2. All right, we got an e. So, okay, it's okay. Well, e's are fine. So we make that y. And then we're going to switch our x and our y. So x equals e to the y minus 5. We want to get this part is the thing with the exponent. That's the part with the y. I need to get that by itself. So I add my 5. So after I've done that, I have to do the log switch. So it's log base e of x plus 5. Now it's the whole thing over here. So put it in parentheses, because it's that entire thing. Otherwise it might not look like it's in parentheses, equals y. So the inverse of k is equal to log base e. But if you recall, log base e is just ln of x plus 5. This is so much fun, Ms. Barris. Thank you for showing us this. I didn't know math could be so much fun. Alright, let's change colors. Let's go to blue. So I'm going to change this to y. Switch the x and the y. So x equals 10 to the y minus 3 plus 7. Remember, just the x and the y switch. This is the mess with the exponent. So I have to get rid of the 7 before I can do my log switch. Okay, now this thing is isolated, so it's log base 10 of this whole mess is equal to y minus 3. Okay, and then the y needs to be by itself, so I simply add my 3. Now the 3 can't be added, and that's one reason why the parentheses are needed here. You can't add the 3 into there. Bad. Okay, remember log base 10 is just log. So it's x minus 7 plus 3. So this plus 3 is not actually inside the log right now. Okay, if I were to plug it in my calculator or something, a value in for x here, I would do log of x minus 7 in parentheses and then plus 3. So just be careful of that. Parentheses matter. I don't know where it came that you decided to think that it doesn't, but parentheses matter. All right, so now we are going to find the inverse of log. So we're just going to go the other way. Process is basically the same though. We got to isolate the log and solve. So x equals log base 3 of y. Now realize when you're doing this, if you have finding the inverse of a log, no log in inverse. Crazy, right? There will not be a log in the inverse. So when I find the inverse, 3 to the x equals y, bam, she's done. Of course, there's always an easy one, right? That's it. We do the log switch. So when we do this one, same idea. This is y. Okay, these parentheses matter. Oh, my bad. I've switched my x and my y already. So this would be x, and this is y minus 2. So this is the part. This is the log base 5 of y minus 2. I have to get that by itself. So I need to divide by 4. So it's x over 4 equals log base 5 of y minus 2. So now this is isolated. So I just do my log switch. 5 to the x over 4 equals y minus 2. Now my log is gone. And I add 2. So the inverse of g is equal to 5 to the x over 4 plus 2. That's not in the, this 2 is not in the exponent, it's just being added to whatever the exponential is. Awesome. I don't know why I did that. Over here, just another example. Why don't you take a second and try this one on your own, and we'll show you the answer. And so here's the answer to this one. 10 to the x plus 5 over 4, all that minus 3. So just be careful. You have to isolate this log of x plus 3. So I had to add the 5 and divide by the 4 before I could do the log switch. There was no value on the log here, so remember, you had to remember that was 10. When there's no number there, it's log base 10. So it's 10 to the x plus 5 over, whatever this is, plus 3, and I subtracted 3. That is all. Pretty fantastic. So try this one, and we'll be right back. All right, for this one, a few things you had to remember. The ln of y, after you switch the x and the y, that's what you have to get by itself, so you got to get rid of the 7. So I got rid of the 7 here. And then you have to remember that the ln is the same as log base e, so e is the base here. You don't have to write this step, of course, but if you don't remember or if it helps, that's good. So e is the base, x over 7 is the exponent, and it equals the y, and you're done. Okay, so that's the inverse of t is e to the x over 7. Have a good day.